Welcome to nth roots and rational exponents. So, you guys are used to square roots. We've been doing those quite a bit. And cube roots we're just starting to work with, but that's just scratching the surface. We can have all different kinds of roots. So, the first thing we're going to talk about is just what you're used to, the square root, and you can put a little 2 there if you want. The square root of a is equal to a to the 1/2. Something that you may or may not have known in the past is we know that the square root of 4 is equal to 2. But did you also know that 4 to the 1/2 power is also equal to 2? I'm going to prove that to you in just a second. And the cube root could also be written as a to the 1/3 power. And the nth root of any number can be written to a to 1 over that nth root that you're trying to find. So one of the very useful tools you're going to have for this chapter is being able to rewrite radicals as an exponent. Okay? So here's the proof. Let's say that we have the square root of a times the square root of a. And we know that the square root of any number times the square root of that same number is going to be equal to just that number. So let's just call the exponent k instead. So a to the k times a to the k is equal to, well, still a. We know that when we multiply, we add exponents. So a to the k times a to the k is a to the 2k because k plus k is 2k. So now that we have our variables with 2k and 1, we just set 2k equal to 1 and we find that k is 1/2. So that proves to you that the variable raised to a 1/2 power is the exact same as a square root. Now here's a couple other things you need to know. For any number raised to an exponent, if the exponent is odd, there is only going to be one real root. So an example, what if we had the cubed root of 8? We know that the cube root of 8 is 2. What is the cubed root of a negative 27? The answer is a negative 3. Because with odd roots, we can have negatives. Think about it. Negative 3 times a negative 3 is a positive 9, times a negative 3 brings you back to a negative 27. So you are allowed to have negatives inside of an odd root. And you will only have one real nth root when you are working with an odd exponent or an odd root. But when it's even, this is something that you already are pretty familiar with. If it's even and you are taking, say, the square root of 4, we know it's plus or minus 2. If we are taking the square root of 0, we know it's just 0 because 0 is neither positive or negative. And if we take the square root of a negative 9, we would say plus or minus 3i, but that is an imaginary root. When you take the square root or the even root of a negative, you have no real roots. Okay? So those are just a little bit of pre-game activities for something that you've been working with, but we just went a little deeper. Now we're going to rational exponents. Yes, you can have exponents of 2/3, 3/5, 5/2, all sorts of crazy different exponents. So, it is very important that you know how to write them in different forms. So, an example right here would be a to the m over n. We can rewrite that in one of two ways. The denominator is your nth root that goes in front of your radical symbol, or in this little pocket, shall we say. And the numerator is the exponent of what you're taking that nth root of. Now, you can write it in one of two ways. You can write it inside the radical, or you can write it outside of parentheses around that entire radical. So, for an example, if we have 2 to the 3/5 power, we can write that as the 5th root of 2 cubed, or you can write that as the 5th root of 2 all of that raised to the third power. Either way you do it, you're going to get the same answer. So as long as you find one that you're happy with, you just go right ahead and work with that one, okay? If there's a negative, the negative's going to stay inside, okay? And if you raise to a negative exponent, that's the same thing that it meant back in the day, where a negative exponent does not mean your answer is negative. It just means it's the reciprocal, so this just jumps down to the bottom instead. Okay? So all of that is just the foundation for the problems we're about to do. So what we're about to do is we're just about to start simplifying some of these, just putting some of those rules to work. So number one is the cube root of a negative 125. You can probably do that in your head, but being able to write certain numbers as a power is pretty helpful from time to time. So I'm going to show you how to do this in a way that you probably weren't thinking. We can take the cube root of, we can rearrange this, and we can call negative 125 as a negative 5 to the third power. So let's rewrite that as an exponent. So we know that this is our denominator, this is our numerator. So we can call this negative 5 to the 3/3 power, which we know is negative 5 to the first power, which gives you your answer of negative 5. Again, you probably could have just done that in 2 seconds in your head without thinking about it. But we're going to start getting to some more challenging problems, so being able to manipulate radicals and exponents is going to be beneficial to you. So this next one, we have 9 raised to the 3/2 power. So I'm going to show you how to do this problem in 2 different ways, okay? So the first way I will show you is with radicals. We can rewrite this as the square root of 9. And you do not need to put the little 2 in front. We know from the past that that is a square root symbol when there's no number, but if it makes you feel better, you can write it. So we're going to take the square root of 9 and we're going to raise that to the third power. We know the square root of 9 is 3. Raised to the third power is 27. So there's a way you can work with it when you're talking about radicals and changing them from an exponent to a radical. Another way you could have done this problem is just keeping it as exponents. But that would be still changing 9 to what we know is 3 squared. Now, that's still raised to the 3/2 power. Notice I did not change the exponent we started with 3/2. All I did was change the 9 to a 3 squared, because we know 3 squared is 9. Now, previous rules have told you that when you raise an exponent to another exponent, you multiply. So 3/2 times 2 is 6/2. So we have 3 to the 6/2 power. And we know 6 divided by 2 is 3, so this is just 3 cubed, which we already know is 27. Again, it's a little confusing until you practice. However, being really good at manipulating exponents and radicals is going to be a very big help for you this chapter. Okay? So, number 3 says 32 to the negative 2/5 power. So the first thing you're going to end up doing with this example is just rewriting it to 1 over 32 to the 2/5 power. Now, if you think you can handle this, I'm going to ask you to pause. But I'm going to just continue working this out for you so you can see how this can be simplified. And yes, I know you can use your calculator to simplify 32, but in the future that's not going to be possible. So I'm just going to do this by hand. So first thing I'm going to do is I'm going to rewrite this 32 as 1 over the 5th root of 32 squared. And let's move back over here. We know 32 can be written as 2 to the 5th power. So this is going to be 1 over the 5th root of 2 to the 5th power, which we know is squared. So 1 over the 5th root of 2 to the 10th. Let's rewrite that back as a exponent. So this is 2 to the 10/5, which we know is 1 over 2 squared, which is 1/4. Again, I did that in a way that you're probably not thinking about. Yes, I understand. You probably could have done that in 2 seconds with a calculator. But when we start having variables on the inside, you're going to want to have these skills. How do you use a calculator to take the cube root of 8? Well, there is a cube root button, but if you remember at the very beginning of the lesson, we said that a cube root can be rearranged to a 1/3. So what I would do is 8 raised to the 1/3 power, and that will just straight up give you your 2. So if you're looking to use your calculator, knowing how to use it is very important. So to take any root, you can just use your calculator, but if it doesn't simplify nicely, you are going to need the skills I'm talking about now, being able to rearrange radicals and exponents. Okay? How to solve. If this was an x squared problem, we would just take the square root of both sides. But number 1 is an x to the 4th problem. But we still solve these questions the same way. The first thing you want to do is divide both sides by 6. You get x to the 4th is equal to 625. So now, all you have to do is take the 4th root of both sides, and we get x is equal to, and if you use your calculator and you type 625 raised to the 1/4 power, it would tell you that it is 5, but since this is an even root, remember it's plus or minus 5. Number 2, the same thing we did back in the day. To get rid of a group that's raised to a 3rd power, we're just going to cube root both sides. That's going to leave us with x plus 1. And that's equal to, what is the cubed root of 18? Well, you do not know how to simplify this to get an exact answer yet, so calculator purposes, we would just type 18 raised to the 1/3 power, and that would give you x plus 1 is equal to 2.621. Subtract 1 from both sides, and x is equal to a 1.621. Now that is an approximate answer, just so you know. And I believe the next video, we're going to show you how to simplify radicals. Okay? So the last 2 problems, if you think you can handle these on your own, go ahead and pause the video, round to your 3 decimal places, and we'll see if you get them right. So you should have 3.585 for number 3. And number 4, because you are taking an even root, remember the 4th root of 67 is plus or minus 2.861. So add 1 and you're going to end up with 3.861 and negative 1.861. All right, so that is your introduction to rational exponents and nth roots. This is Longo. I'm out. See you. Bye.